Hello, Transitional Math students. Mrs. Robinson here to practice benchmark chapter 7 with you. Let's get started. Okay, number 1 says, Bradley rents a fishing boat for the day. The total cost for gasoline is represented by this expression, 3.5 times m plus 15. What is the constant in the expression? So this is just a vocabulary check. Do you understand what constant means and what coefficient means? Constant means a number. Just a number, not next to a variable, just by itself. The numbers you've been used to working with since elementary school. The only number we have by itself is 15. There is another number here, a constant, but we call this a coefficient because it is co with this variable. This is telling me there's 3.25 m's here, not just the number 3.25. So this would be a coefficient. This right here is a constant. It's the number just by itself. So, which is the constant in the expression? It's 15. All right, let's go on to a triangle, or number 2. A triangle has the side lengths of 4x minus 10 units, 2x plus 6 units, and 5x units. Which expression represents the perimeter? So if you're one who's visual and you like to draw a triangle, go ahead and draw one. And you can say, all right, one side is 4x minus 10. One side is 2x plus 6. And one side is 5x. Now, hopefully, based on what x is, the hypotenuse is your longest side, how I wrote these. And that value for x will tell us what these side lengths are, but we don't care. We just need an expression to figure out the perimeter. To get the perimeter, you just add up all the sides. So that expression would look like this. 4x minus 10. Now I'm going to drop the parentheses because I'm not multiplying by anything here. So I'm adding plus 2x plus 6 plus 5x's. Now, in order to simplify this expression, I need to combine any terms that are alike. So I like to do this. Underline my terms that are alike in blue. My x's here are like terms. They're exactly the same. They're all x's. So there are 4 x's here, plus 2 more x's. That makes 6 x's, plus 5 more x's. That makes 11 x's. So I have 11 x's here. And now my other like terms are just my constants. So just my numbers. I have negative 10. The negative goes with the 10. I have 6. And those are my only constants. So I'm going to go negative 10 plus 6. It's a negative plus a positive, different sign. So I actually subtract the numbers. And I get 4. But because the negative is with the bigger number, I keep the negative. It's minus 4. So negative 10 plus 6 is minus 4. And my expression will be 11x minus 4. Units. It is a unit, whether it's centimeters or inches or whatever it is. So this would be C. Okay, on to the next one. All right, which expression has the same value as negative 4 times the parentheses quantity negative 5 plus x? Now, in the lessons in chapter 7, you learned, you should have relearned about the distributive property. That's a property you probably went over in elementary school, but let's go over it. When you have a parentheses on the outside, this distributes to both terms. So you have to take negative 4 and multiply it by negative 5, and then negative 4 and multiply it by x. So negative 4, if I just wrote this out, it would look like this. Negative 4 times negative 5, and that's a plus negative 4 times x. And then you could, of course, simplify this, but it looks like it's leaving it in this form. Negative 4 times negative 5 plus negative 4 times x. That's exactly what it looked like when I first distributed it. Now, if I simplify it, negative 4 times negative 5, a negative times a negative is a positive, so I get positive 20. Negative 4 times x is negative 4x, so this becomes plus negative 4x, or I could just write minus 4x. This is what it looks like simplified, and you'll notice that wasn't one of our choices. So I'm going to pick A. All right, let's go ahead and find out the equivalent. This is equivalent to which value? So it looks to me like it does want me to finish this problem and simplify. So I'm going to go negative 2 over 5 times 15 minus 5. Now, this negative can go with the top or the bottom. I'm going to leave it here at the top. I'm going to go and distribute. this whole quantity times 15, this whole quantity times -5. Let's write that out over here. So this would be -2 over 5 times 15, which is the same as 15 over 1. And then a negative times a negative is a positive. So -2/5 times -5 is going to give me a positive. And then I'm going to write 2 over 5 times 5. Now I could have left the negative and negative and then figured it out at the end, but it's easier to get rid of it right away. A negative times a negative gives me a positive. And I have 2/5 times 5. All right, so here I've got -2/5 times 15. I'm going to go ahead and simplify. This is the same as 15 over 1 if you like to see it like this, where you could cross cancel. Let's go 5 goes into 15 3 times, and I'm left with nothing else cancels, and 5 goes into itself 1 time. So I'm left with -2 times 3 on top, which is -6, over 1 on bottom, because 1 times 1 is 1. And that just simplifies to -6. So -2/5 times 15 is -6. And work this. If you are more comfortable with putting a 1 here so you can see the fractions, go ahead and do that. You multiply the tops and you multiply the bottoms, but first cross cancel. 5 and 5 cancel to be 1 and 1. And if I multiply across the top, 2 times 1 is 2. And across the bottom, 1 times 1 is 1, which just gives me 2. So -6 plus 2 is what I have, and -6 plus 2 is -4. When there are different signs, you subtract and you add the sign, attach the sign of the bigger number. So -4 is my answer to number 4. All right, on to number 5. Okay, Mateo and Haley both collect coins. Mateo has 8 more coins in her collection than Haley. Which expression represents the total number of coins in both collections? Okay, so we want coins. It looks like they use the variable c, so let's use that. Let c equal the number of coins. Oh, C-O-I-N-S. I can do it, guys. Let's make that prettier. Okay, the number of coins. So for Mateo, his coins would just be, Mateo and Haley, they both collect. Mateo has 8 more coins in her collection than Haley. And if, it looks like Mateo's a girl according to this pronoun. Sorry, I was just looking at that. I just said a boy. But if Mateo has 8 more coins in her collection than Haley, Mateo's would be C plus 8, and Haley's would just be C. So Haley would have the number of coins, and Mateo would have that same number plus 8. Now, which expression represents the total? So you're just going to go Mateo's coins, coins plus 8, and then Haley's coins is just coins. And that would be the total number of coins. Now we're just going to add them together. 1C plus 1 more C is 2 C's, and then plus our constant of 8. 2 C's plus 8 would be our solution, so A. All right, on to the next one. Which of the following expressions can be written as 1/6 times x plus y? This is just checking your distributive property knowledge again. So let's see, if I do 1/6 times x and 1/6 times y, it would look like this. 1/6 times x plus 1/6 times y. And then if I look at my choices, there's an xy here and x, not that. 1/6 xy, nope. X over 6 times x or y over 6, no. And actually, let's talk about that in 1 second. 1/6x plus 1/6y, yes, it's D. Now, you could have written this. This is 1 over 6 times x, and x is the same as x over 1. So I'd multiply across the top and get x, and multiply across the bottom and get 6. This could be written as x over 6, plus, if this was y over 1, and I'll write it just so you can see, 1 times y is y. 6 times 1 is 6. So this would be y over 6. Now, if they had written x over 6 plus y over 6, not x over 6 times y over 6, that would have also been valid. So this and this are equivalent. All right. Let's go to number 7. Which of the following expressions correctly combines like terms? So basically they're giving us 4 problems here and say, check these, see if they're right. So let's look. This multiple choice problem turns into 4 problems, really. So let's look at the first one. We want to know if this whole thing is equal to 6x plus 3y. Does this all simplify to give me 6x plus 3y? We'll check it. If I combine like terms, so only the x terms I will combine. So I'm going to go 4x's and 2x's. That will give me 6x's. And then my constants, this is actually, I kind of wrote over it so it's hard to tell, but that's a plus. So let's do our constants in green. So 7, and there's no other constant, so I'm just going to write plus 7. And then let's do our y's in blue. I've got minus 4y's. So if I combine all my terms that are alike, I get 6x plus 7 minus 4y. That is not 6x plus 3y. So that's not that term. And they got that from subtracting 7 minus 4y, combining this into 3y, but you can't do that because this is just a constant 7. It's not 7y's. If this was 7y's, then I could combine these terms. Okay, let's check this one. Does this equal 4x plus 3y? Well, 2x's and 2x's give me 4x's. Now let's go green for the next terms. We got y's here, 7y's and negative 4y's. Well, 7y's minus 4y's does give me plus 3y. So I get 4x plus 3y. Yes, it is this one. Now, I could check these to make sure, because what if it was C and D? What if there is more than one correct solution? So let's just check. Let's go through, and we're going to go 2x's, and 2x's give me 4x's. 7y's and negative 4. There's no other like terms, so I'm just going to write plus 7y minus 4. Does that give me 4x plus 3? No, not that one. And then check this last one. 4x's and 2x's give me 6x's. And then I was changing colors for the next term. 7y's plus 4y's, so 7, 8, 9, 10, 11 y's. 6x plus 11y's is not this, so that's a no. That is not true. So it's B. All right, on to the next one. Okay, what's the GCF, the greatest common factor of 100, XYZ, and 25XZ? Now, greatest common factor, the whole point of it is because you're going to pull out or undistribute the biggest term that these have in common. All right, now, I'm going to show you the way the textbook does it, and then as you guys get good at this, you're not going to have to do it in such detail. So I'll just show you this way, and then I'll show you how I would do it. So 100, X, Y, Z, and 25. We've got 25 XZs. Okay, we want their greatest common factor, or the greatest term that they both have in common. I think of it, what's the biggest number that divides evenly into this term and this term? That's how I think of it. Now the book has you factor out 100 and factor out 25. So doing a factor tree of 100, do the prime factors, factor down to prime numbers, meaning no other number divides into it but 1, right? So 100 I could break this variety of ways, but let's try 50 and 2, okay? Once I get a prime number, I'm going to circle it, okay? So there's one of my factors. And then 50 breaks into 2 and 25. Once I get to a prime, I circle it. This one has to go more. 25 is 5 times 5. 5 and 5 are both primes. Nothing else divides into them. So the prime factorization of 100 is going to be, I'll write it in blue, 2 times 2, so there's 2 2's, times 5 times 5. Now, if I had x squared, I would write x and x, but I just have one x. So 1x, 1y, 1z. Now let's do the prime factorization for 25xz. So 25, I need to prime factor that. 25 is just 5 times 5, and those are prime numbers. So I've already prime factored that, and let's write that out. So that will be 5 times 5, and then times x times z. This isn't z squared or anything. If that was the case, I would write z twice. Now, your greatest common factor are going to be the factors they have in common. So they have a 5 in common, so I'm going to write that here. They have another 5 in common. I'm going to write another 5 they have in common. They have an x in common, so I write that. And they have a z in common. And if I simplify this, 5 times 5 is 25. So 25xz is the greatest common factor of these two terms, 25xz. So that's how you would write it out if you really wanted to find it methodically. Now this is how I do these. The easiest way to figure out your variables, what is the greatest common variable, you look for the largest variable that divides evenly into these. Well, they both have an x, so I write that. They both have a z, I write that. They don't both have a y, so leave it out. Okay, so the common factors for the variables are xz. Now, what's the biggest number that divides evenly into 25 and 100? Well, 25 goes into 100. So the biggest number that divides into 25 is 25. The biggest number that divides into 25 and 100 is 25. So the biggest number that divides into both of those is 25. 25xz. And that's how I do these as I get better at them. If you need to write out the primes and make sure you've done it right, go ahead. If you can go, all right, what's the biggest number that divides evenly? If one divides into the other one, it's going to be that number. If there's not a number that divides into that, you have to think, what's the biggest number that divides evenly to 25 and 100? And the variable parts are easy. All right, on to 9. Which expression is the equivalent to 1/4 4 plus 9? Now, if I were working this problem, I would do this. Do what's inside the parentheses first, 9 plus 4. So I'd go 9, 10, 11, 12, 13, and I would write this as 1/4 times 13. And then I would go ahead and do the multiplication. 13 is the same as 13 over 1. So 1 times 13 is 13, and 4 times 1 is 4. This doesn't reduce. It's an improper fraction, or you can divide it out and make a proper fraction, or a mixed number if you want. But if you'll notice, that's not one of the choices. They're checking distributive property again. They just want to know, if I multiply this times this and this times this, what is that? Okay. Well, I'm adding here, not multiplying. So it's not this. Is it 1/4 plus 13? No. Times 1/4 plus 13? That's weird. No. I'm going to go 1/4 times 4. 1/4 times 4 plus 1/4 times 9. 1/4 times 9. Ding, ding, ding. That's what I'm going to do. All right, let's go on to number 10. Real quick, I want to go back to number 9 and just remind you, if you do distribute first before you do what's inside, because I did what's inside, that's the order of operations, but if you did distribute first, you would still get the same answer of 13 over 4. Let's just check it. 1/4 times 4, that's 1/4 times 4, plus 1/4 times 9. Well, 1/4 times 4 would be 4 over 4, or 1. Plus 1/4 times 9 would be 9 over 4, which is equal, if I add these, they have the same denominator, so I can add 13 over 4. Okay, so you get the same answer. All right, let's just check 10. Admission to an art museum is $12 for students. Which expression can be used to mentally compute the total cost of admission tickets for 60 students? So you're thinking in your head, how much is this going to cost if I take 2 classes to an art museum and it's $12 per student? I just want to do this in my head. I don't want to write it out. Well, if I have 60 students, 60 times 12 is a little hard. What I would have done is I would have gone 12 times 6 and then add a 0, because I can do that one in my head. I know 12 times 6 is 72, and then I would add a 0, 720. That's how I do it. Now, distributive property-wise, you could have done this. Well, I've got 60 students. Easy thing to do is 6 times 10, right? Because if I do 60 times 10, if I do 60 times 10, I know that's 600. And then if I also add on 60 times 2 more dollars, times 2, well, 6 times 2 is 12, and add a 0, that's 120. So then I could add these. Well, 600 plus 120 is 720. That's another way to mentally do it. Which one of these makes the most sense? Well, 10 times 30 plus 30, that's not even what you're doing. What you're doing is 12 times 60. Okay, so you could have gone 12 times 30 plus 30. So not 10 times 30 plus 30, that doesn't even work. 6 times 12 plus 10, well, 12 plus 10 is 22. So you're doing 6 times 22? No, you're doing 12 times 60. So that doesn't even make sense. 12 times 2 is 24, plus 60 times 10. Well, this isn't even the value we have. So if you want to do 60 times 10, that's what we did, yes. And then we do 60 times 2, not 12 times 2. That doesn't make any sense. Let's look at this one. 60 times 10 plus 2. That's what we did do. If I distribute this, I'm going to go 60 times 10 plus 60 times 2. And that's what we did do. 60 times 10 plus 60 times 2. It's just one way to break it out mentally. It's easy to multiply by 10. So take your $12 and make it be 10 bucks. You have 60 students. Make it be 10 bucks and 2 bucks. Because that's easier. And I can go 60 times 10 bucks. All right, that's going to be 600 bucks. And then 60 times 2 bucks, that's going to be 120 bucks. That's how we broke it out here. All right. There is more than one way to do this. All right, guys, number 11, I debated on whether I would leave in or not. And the reason is, it asks you for the cube measures of a triangle. What are the angle measures of this triangle? And you actually need to use an equation to solve this. And we're just doing expressions, but you guys should already know a little bit about equation solving from 6th and 7th grade math. And this should be a little bit of review, so I'm going to leave this in. And I left a hint on the actual test. Remember, triangle angle measures, I don't know if you guys remember this, but all the angles of a triangle, angle plus angle plus angle, add up to be 180 degrees, okay, equals the angle measures of a triangle. Angle sum. Okay, always all the angles sum up to be 180. Doesn't matter what kind of triangle you have, they always sum up to be 180. It looks like a weird equal sign. So take that in mind, and they give you acute angle measures. Acute means it's cute. They're acute angles. It means all the angles are less than 90. Okay, that's what acute means. Acute angle measures of a triangle are x plus 25, x minus 5, and 2x minus 40. This looks like a right triangle, so I'm just going to erase that and draw us an acute triangle. Okay, so maybe something like more like this. Okay, all the angles are less than 90. So we would have maybe an x plus 25 here, and then an x minus 5 here, and a 2x minus 40. This is definitely not to scale. Okay, the 2x minus 40 here. There's your three angles. Now you know all the angles add up to be 180. So what are the angle measures of the triangle? Here's what I would do. I would go x plus 25. That's one angle measure, plus x minus 5, that's another angle measure, plus 2x minus 40, that's another angle measure. And you know you have to add those all up. They have to equal 180 because that's what all triangles add up, angles add up to be, 180. Now let's go ahead and combine our like terms and figure out what x is, and then we can figure out the angle measures, right? So our like terms, all the x's, let's underline them. I have 1x plus 1x plus 2x's. So 2x's, 3x's, 4x's. 4x's. Okay, so I've done my x's. Now let's combine our constants. We've got 25 and then minus 5 and then minus 40. So if I go 25 and minus 5, that's 20. And then 20 minus 40 is going to give me a negative 20. Okay. Now if I add that together, I'm going to set that equal to 180. Now this is where you actually have to solve an equation. Okay, you could guess and check and plug in here, and you could plug in these angles to see which ones work and add up to be 180, or you could just figure out what x is and then plug it into each term. So by doing that, if you have an equal sign, remember you have to keep a balance on both sides. So whatever you do to this side, you have to do to this side. So I want to get x by itself. That's my goal, to figure out what x is. So I peel this off first. I do the opposite operation. I'm going to add 20, and if I do it to one side, I do it to the other side. And when you add to both sides, that eliminates this. Negative 20 plus 20, that eliminates to 0. And then I bring down my 4x. I bring down my equal sign. And 180 plus 20 is 200. Now my goal is to isolate my x. I have 4 times x. The opposite operation of multiply is divide. So if I divide this side by 4, I divide this side by 4. And I'm going to get x equals, well, 200 divided by 4, I don't know that off the top of my head, but I know what 20 divided by 4 is. 20 divided by 4 is 5. And then add the 0, so I get 50. Right? I know x is 50. Now come up and tell me what each of the angle measures are. Well, I plug in x here, and I'm going to go 50 plus 25. 50 plus 25, 50, 60, 75. So 75 is one of them. All right, so I'm going to write it right here. Sorry, it's kind of crunchy. And then just erase here so you guys can see this. Okay, let's write it right here, 75. And then I'm going to go 50 minus 5. Well, 50 minus 5 is 45 degrees. And then I'm going to plug in 50 here, and it's going to be 2 times 50 minus 40. Well, 2 times 50 is 100. 100 minus 40 is 60. So there are my degrees, 75, 45, and 60. 45, 60, and 75. So it is A. Now, you could have guessed and checked this, but this is a sum. You're going to add these angles together, just like you did. This is your expression part. And then you do have a little equation part here. All right. So on the test, remember, angles add up to be 180. All right. Which expression has a coefficient of 0.5 or 0.5? So looking at these expressions, remember coefficient, think it commingles with your variable. Which one is commingling with your variable? Not a constant by itself. So this one does commingle with x, but it's a negative. It didn't ask me for negative 0.05, or excuse me, 0.5. This one has a 0.5, but it's a constant. It's not commingling with x. Okay. This one has 0.5x. So there is my coefficient of 0.5. This one has a 0.5, but it's a constant by itself. So it's C. This one is the only expression that has a coefficient of 0.5. Once again, make sure you understand what coefficient means. It's the term in front of your variable. It tells you how many of these variables you have, and what your constant means. It's your number by itself. All right, which of the following expressions cannot be factored? All right, to be factored, you have to have a common term. So it's like undoing the distributive property. Factoring is the undoing of the distributive property. So if you look here at this first one, do they have a greatest common factor that I could undo, pull out? Well, they both have an x term. So yes, I could factor out an x. And if I factor out an x, it's like dividing it out. If I pull it out of here, I'm left with 1/2 y. And if I pull it out of here, well, x divided by x, anything divided by itself is 1. And then you can check to see if you factor correctly by distributing and see if you get back to that. So if I multiply this by x, I do get 1/2 xy. And if I multiply this by x, I do get 1x. So yes, this one can be factored. Check. How about this one? In this term, is there anything these two have in common that I could divide out or factor out? 4x is here and a y here. So they don't have a coefficient in common. They don't have a variable in common. So this one has nothing to factor out. So I'm going to go with B. This one cannot be factored. It's most factored. Let's just check C and D just so we understand the concept. X over 4 plus y over 2. You might think these don't have anything in common, but alas, they do. They don't have any variables in common, but x over 4 is the same as 1/4 times x. y over 2 is the same as 1/2 times y. 1/4 and 1/2 do have a factor in common, okay? I can actually factor out, hold on a sec. I can actually factor out, if you look at these, they have a 2 in common, okay? So I can actually factor out a 1/2, and it would look like this. 1/2, if I factor out 1/2 out of this, it leaves me with, I know this is true, 1/2 times 1/2 equals 1/4. So if I factor a 1/2 out of this, it leaves me with 1/2 x. Plus, if I factor a 1/2 out of this, it's like dividing out the 1/2, it leaves me with just y. Check it and see if this gives you back that. Well, 1/2 times 1/2 x would be 1/2 times 1/2, which is 1/4 x. 1/2 times y is 1/2 y. So this does factor. And this one, what do these two have in common? A 4. I could factor out a 4. It's like dividing it out. Divide out a 4 and you're left with x, y. Divide a 4 out of here. Well, 4 divided by 4 is just 1. See if it goes back to this. 4 times xy would be 4xy. 4 times 1 would just be 4. And it does. So these all factor. So it's just B. Okay. 14, the expression 2.2x plus 8 represents the number of miles Trent jogged during a race. So he jogged this many miles, where x is in hours, okay? And 5x represents the number of miles that Ling jogged during the race. So if x represents the number of hours, if she jogged for 5 hours, she would have gone 5 times 5, which is 25 miles, okay? Write an expression to show how many more miles Ling jogged than Trent. So Ling jogs more miles, 5x miles. And then, let's see, Trent jogs this many miles, 2.2x plus 8. So I'm going to take the number of miles that Ling jogged and then subtract the number of miles that Trent jogged. And that will equal how many more miles Ling jogged than Trent. If Ling jogged 25 and Trent jogged 10, I would just subtract them, and that would tell me how many more she jogged. So I'm just going to say, well, 5x minus 2.2x plus 8. There's your expression that will represent that. Now you could simplify this, distribute this negative sign. Remember, when you minus, it's like an imaginary -1 you're distributing. You have to take this minus and this minus. So if I distribute an imaginary -1, this would be 5x. So this would be minus 2.2x, and then distribute that -1 over here, minus 8. So many students forget to subtract this when they do these types of problems. So when you subtract and you have a parentheses, that subtract distributes to both terms. All right, if I go 5x's minus 2.2x's, that's going to give me, and I'm going to write it up here, that's going to give me 2.8x's. And these are like terms, so I combined them, and then I just have minus 8. So you could have told me this expression or this expression. This is the expression, and this is the simplified version. Both are fine. Let's look at 15. An area of a rectangular hot tub cover is, I like to draw things so I can picture. Okay, if it's rectangular hot tub cover, and that was an ugly rectangle. I'm going to use this. That's better. Okay. And you know an area is the length times the width. Okay, so two terms. They gave us the area of the rectangular hot tub cover, and they said it was 8x minus 2 units, square units, unit squared. So whether that is feet squared or whatever the unit is, okay? This is our area. What are the possible dimensions of the hot tub cover? Well, to get this area, I had to do this times this. I had to multiply two things to get this. So what could I possibly have had to get this? So here's what I would do with this. Two things multiplied together to give me 8x minus 2. Let's go ahead and factor out the greatest common factor. So what's the biggest term that divides into 8 x's and 2? Let's look at the constants, okay? What's the biggest term that divides into 8 and 2? It's 2. 2 divides into 2 and 2 divides into 8. So I'm going to pull out a 2. If I do that, if I divide a 2 out of 8, it leaves me with 4, and then I multiply by x. If I divide a 2 out of 2, it leaves me with 1. So if I factor out a 2, I'm left with 2 times 4x minus 1. And if I multiply it back, it's 2 times 4x, which is 8x. And 2 times negative 1 is negative 2. So it works. So look, now I have something times something else. If my width was, let's say my length was 2, my width could have been 4x minus 1. I just needed 2 things to multiply together to give me this. And I did that by factoring it out, and I found 2 things. So the possible dimensions could have been 2 units times 4 units, or 4x minus 1 units. So 2 units by 4x minus 1 units would work. You could write it like this. 2 units by 4x minus 1, that quantity in units. Okay, and I think the book probably writes it like this. If you write it like this, that would be fine also. Okay, guys, that's how you work practice benchmark chapter 7. Email me if you have any questions. And don't forget, I have open tutoring hours on Zoom, so come use that. Okay, have a great day.